In December 1986, 11 Przewalski's horses stepped out of transport crates onto frozen ground at the edge of the Junggar Basin in Xinjiang, northwestern China. They had been flown from zoos in Germany and the United Kingdom into a landscape of gravel desert, sparse scrub, and winter temperatures that dropped below -30. There was, by any conventional measure, almost nothing for a horse to eat. The Junggar Basin is not grassland, it is semi-desert, a vast wind-scoured expanse of stone and dust stretching across the northernmost edge of the Gobi, where annual rainfall barely reaches 4 inches and the growing season lasts only a few months. The 11 horses that arrived that December were the first of their species to touch Chinese soil in over half a century. They had come home to a landscape that looked, to human eyes, like it had nothing left to offer them. By 2025, the population in China had passed 900, roughly a third of the global total. Wild herds now range across 4 Chinese provinces: Xinjiang, Gansu, Inner Mongolia, and Ningxia. In the Kalamaili Nature Reserve alone, free-roaming bands have spread across thousands of square kilometers of desert steppe, digging through snow to reach buried vegetation, locating water sources satellite surveys had never mapped, and maintaining grazing patterns that arid land ecologists are now studying as a working model. The IUCN had previously classified the species as extinct in the wild and has reclassified it to endangered, a shift that ranks among the most improbable recoveries in the history of large mammal conservation. The animals are still expanding. Here is the whole story, from the evolutionary lineage that makes this animal the only true wild horse left on Earth, through the hunting and habitat loss that wiped it out everywhere it had ever lived, through the zoo-based genetic rescue that kept the species alive on paper, to what 40 years of reintroduction science are now revealing about what happens when you return a desert-adapted megaherbivore to a landscape the rest of the world had written off. Most coverage of Przewalski's horses cuts off at the zoo enclosure and calls the animal a living fossil. This account stays with the herds across 4 decades of field data, through the bottleneck that reduced the entire species to 12 wild-caught founders, the captive breeding crises that nearly ended the project before it started, the first foal born on Chinese soil in 1988, the 2001 release into Kalamaili that had tested whether a zoo-bred horse could survive a Gobi winter, and the peer-reviewed evidence of what these animals actually do to an arid ecosystem when given space, time, and no fences. The sourcing throughout is the IUCN Red List assessment for Equus ferus Przewalski, peer-reviewed reintroduction records from the Xinjiang Wild Horse Breeding and Research Center, and population monitoring from the Kalamaili Nature Reserve. None of this is theory. It is what 40 years of field data confirm. To make sense of what the horses are doing now, the animal itself has to come first, because losing it meant losing something no domestic horse on the planet can replace. The Przewalski's horse is not a feral horse, it is not a Mustang, it is not a domestic breed gone wild. It is the only surviving subspecies of truly wild horse on Earth, an animal whose lineage diverged from the ancestor of all domestic horses roughly 500,000 years ago. Americans tend to picture Mustangs when they hear the word wild, but Mustangs descend from Spanish horses brought to the Americas in the 1500s. They are feral, not wild. The distinction matters because the Przewalski's horse carries genetic, behavioral, and physiological adaptations shaped by hundreds of thousands of years in some of the harshest landscapes on Earth, adaptations no domestic breed retains. An adult stands about 13 hands, roughly 4 feet 4 inches at the shoulder, smaller and more compact than most domestic breeds. It weighs between 550 and 750 pounds. It is stocky, muscular, thick-necked, with a large head and short, powerful legs. The coat is dun, sandy beige, with a dark dorsal stripe running from mane to tail, dark lower legs, and a short erect mane that does not flop the way a domestic horse's mane does. It carries 66 chromosomes compared with the domestic horse's 64, a fundamental genetic difference that confirms its status as a distinct subspecies. What makes it ecologically irreplaceable is the role it plays in landscapes where it evolved. It is a desert-adapted grazer that maintains open steppe habitat through feeding, movement, and social structure. A harem band, typically a stallion, several mares, and their offspring, moves across enormous home ranges, grazing selectively on grasses, sedges, and shrubs. In winter, the horses use their hooves to dig through snow and frozen ground to reach buried vegetation, a behavior called cratering that no domestic horse performs as efficiently. Their movement distributes seeds across the landscape. Their dung creates nutrient hotspots in otherwise barren soil. Their selective grazing prevents any single plant from dominating, holding the plant diversity that supports the entire desert steppe food web. What 40 years of those behaviors have produced across the Junggar Basin is something the data documents in detail later. The ecological effects on record now are not what the original reintroduction plan projected. Before any of that, the world's last wild horse had been erased from every landscape it had ever occupied. A century without this animal across Central Asia is not just a missing species. It is a missing grazing and trampling regime that maintained the structure of the ecosystem itself. And those functions disappeared across the entire range, from the steppes of Central Asia to the deserts of Mongolia and northwestern China, over the course of a single century. The species was first described for Western science in 1881 by the Russian geographer Nikolai Przewalski, who encountered the horses in the Junggar Basin, though Mongolian and Chinese pastoralists had known them for thousands of years under the name Taki, meaning spirit or worthy of worship. The population was already in decline at the moment of description. Hunting for meat and hides, competition with domestic livestock for water and forage, steady expansion of pastoral grazing into the last wild refugees. By the early 1900s, European animal collectors, drawn by the scientific sensation of a newly described wild horse, organized expeditions to capture live foals for zoos. The methods were brutal. Herds were chased on horseback until the foals fell behind, the foals were seized, and the mares were sometimes shot to keep them from interfering. Of the dozens of foals captured between 1899 and 1903, only a handful survived the trip to Europe. Those survivors, plus a small number already in captivity, became the genetic foundation for the entire species. The last confirmed wild Przewalski's horse was sighted in 1969 in the Junggar Basin of Mongolia. After that, the species existed only in zoos. Every Przewalski's horse alive today, every one of the roughly 2,700 animals on the planet, descends from 12 wild-caught founders and possibly up to 4 domestic horse individuals crossbred into the captive population in the early years. It is one of the tightest genetic bottlenecks of any large mammal that has survived into the modern era. China's next move took 40 years to play out, depended on cooperation between zoos across 3 continents, hinged on a 3-phase plan that moved from captive breeding to semi-wild enclosures to full release, and demanded that zoo-born animals learn to survive Gobi winters with no shelter and no supplemental feed. It came close to failing. In 1985, the Chinese government launched the Wild Horse Homecoming Plan. The Xinjiang Wild Horse Breeding and Research Center was established in Jimsa County, on the southern edge of the Junggar Basin, inside the species' historical range. The mandate was specific: receive Przewalski's horses from overseas zoos, breed them in captivity, and prepare their descendants for release. Every step from this point on was deliberate. The first 11 horses arrived from Germany and the United Kingdom in December 1986, and were held at Urumqi Zoo for 16 months to acclimatize to altitude, climate, and local vegetation before transfer to the breeding center. Additional founders followed, and by 2005, 24 animals from facilities in Germany, the United Kingdom, and the United States had been installed at Jimsa. From those 24, the breeding program produced over 285 foals across 2 decades. Captive breeding was only phase 1. Phase 2, releasing zoo-bred horses into semi-wild conditions, was where the real uncertainty started. On August 28, 2001, 27 captive-bred Przewalski's horses were driven out of their enclosures into the open desert steppe of the Junggar Basin. It was the first time the species had been free on Chinese soil since the 1960s. Walking out of the enclosures was never the question. Surviving was. One full annual cycle later, the data showed both casualties and revelations that reshaped the rest of the program. Some horses died in the first winters. Wolves killed several foals. A highway cutting through the reserve killed 5 horses in a single autumn, 2 mares and 3 foals. Water sources tested at fluoride and sodium levels up to 60% above drinkable standards. The desert was not welcoming these animals, it was running them through a filter. But the horses that survived the first year began doing things no zoo environment had been able to teach them. They formed stable harem bands. Stallions competed for mares in ritualized displays, matching the patterns described by researchers who had observed the last wild populations in Mongolia. The horses located springs, seasonal pools, and snowmelt channels the reserve's management team had not fully mapped. They cratered through snow in winter, clearing down to the buried grasses beneath. They shifted seasonally to higher ground in summer, to valley bottoms during the worst of winter. The casualties were not the headline. What the surviving horses started doing to the landscape was, by the late 2010s, the animals released at Kalamaili had become a self-sustaining herd that ranged well beyond the boundaries the biologists had drawn, and the science was unambiguous. The animals were not just persisting in the desert, they were managing it. From here, the project stops being a survival story and becomes an ecological one. The peer-reviewed monitoring records describe more than a population recovery. They describe a desert-adapted megaherbivore restructuring an arid ecosystem through behaviors so fundamental that the landscape itself responds. Start with the vegetation. In arid steppe systems, the absence of large grazers produces a specific kind of degradation. Dominant grass species grow unchecked, form dense monocultures, accumulate thick layers of standing dead material that suppress new growth, and crowd out the forbs, sedges, and low shrubs that support smaller species. When Przewalski's horses graze, that cycle breaks. Their selective feeding removes dominant plants, opens gaps in the vegetation, and lets a wider range of species establish. The 2022 PNAS study by Ratajczak and colleagues, conducted on bison but documenting the same megaherbivore grazing mechanism, found that this kind of selective grazing nearly doubles native plant richness compared to ungrazed land. The same process is now being recorded across the Przewalski's horse range. Vegetation was only the first finding. What the horses did to water dynamics across the Junggar Basin sat in a different category. In a landscape where water is the limiting resource for everything alive, the movement of Przewalski's horse bands creates what ecologists call landscape connectivity for other species. The horses locate and maintain access to water sources across enormous home ranges. Their trails between water and grazing become paths that other wildlife, Asiatic wild asses, gazelles, Argali sheep, and foxes follow. A study published in 2026 in the Journal of Applied Ecology documented how Przewalski's horses and Asiatic wild asses coexist in the Junggar Basin by partitioning water sources spatially and temporally. Horses drinking at certain springs during certain hours, asses using different sources or different times. The horses do not deplete the water, they organize the system, turning unregulated competition into structured access. They also dig. The cratering behavior, pawing through snow and frozen crust to reach buried vegetation, creates feeding patches that other species exploit after the horses move on. Gazelles and smaller herbivores follow in the craters, reaching food they could not have accessed themselves. The behavior is not altruistic, it is incidental. The ecological effect is the same. The largest herbivore in the system creates access for everything below it. For Americans, the parallel is direct. The same megaherbivore dynamics are being studied in bison restoration projects across the Great Plains, the American Prairie Reserve in Montana, the Tallgrass Prairie National Preserve in Kansas, and tribal bison programs on Blackfeet and Fort Peck reservations. The underlying science is identical. Large grazers create habitat heterogeneity that supports higher biodiversity than any other management approach. The Przewalski's horse in the Junggar Basin and the plains bison on American grasslands are running the same evolutionary program on opposite sides of the Pacific, an ecosystem engineering function that operated for hundreds of thousands of years and was interrupted on both continents by the same force, human overhunting. The full scale of the transformation in the Junggar Basin has not been quantified yet. 40 years of population data from a reintroduced desert horse represents one of the longest-running arid ecosystem megaherbivore datasets in the world. What it reveals about how quickly a desert-adapted species can re-establish its role and how broadly that role benefits other species is still being analyzed, but the trajectory is unmistakable. The third finding was geopolitical. The Przewalski's horse has become something larger than a conservation project. It is a diplomatic species, a working symbol of international cooperation in a field where cooperation is rare. The breeding stock that founded China's program came from zoos in Germany, the United Kingdom, and the United States. The captive programs that kept the species alive during its decades of extinction in the wild were coordinated through an international studbook maintained by the Prague Zoo. Russia's Republic of Sakha received over 120 Przewalski's horses from Canada's Elk Island National Park beginning in 2006 to establish herds in Yakutia, where the closely related steppe bison once roamed and where the climate matches the horse's evolutionary history. Alaska received 100 wood bison from Elk Island in a parallel program. The Przewalski's horse is not a Chinese project, or a Mongolian project, or a European project. It is a species whose survival was negotiated across borders, political systems, and decades, one of the few conservation stories where the Cold War, the collapse of the Soviet Union, and the rise of modern China all played roles in keeping a single animal alive. In Mongolian, the Przewalski's horse is Taki, spirit. In Chinese, Yema, wild horse. The Kazakh pastoralists of the Junggar Basin knew it as an animal that belonged to the landscape the way wind belongs to the sky, present, powerful, not meant to be owned. For more than 50 years, those words described an animal that existed only in zoos. The spirit horse had no steppe. The wild horse had no wilderness. The names carried the weight of an absence stretching from the Gobi to the grasslands of Central Asia. The animal has returned. The words have their referent back. Over 900 strong in China alone. They are running across the Junggar Basin where the last wild individual was seen in 1969. They dig through snow for buried grass in a desert where human observers saw nothing to eat. And they are breeding season after season, fall after fall, in a landscape that had been waiting half a century for them to come home. 11 horses, one breeding center on the edge of the Gobi. A three-phase plan moved from zoo crates to captive enclosures to open desert. 24 founders were pulled from 3 continents. And a population that is now 900 strong is writing its own future across the deserts and steppes of northwestern China, without anyone holding a lead rope. China is not the only country where a returned species is rewriting a landscape in ways no one modeled in advance. In our next video, we go to Idaho, where in 1948, a state wildlife officer threw 76 live beavers out of an airplane with surplus World War II parachutes, dropped them into a valley that would become one of America's largest protected wilderness areas, and accidentally started an ecosystem restoration experiment that has been running for 77 years. 11 horses reshaping a Gobi desert sounds dramatic, until you see what 76 parachuting beavers did to 2.3 million acres of American wilderness when nobody was watching. Your default picture of ecosystem recovery is about to change.